Okay, hello everyone. This is gonna be the VCBM joint VMV panel on immersive analytics. My name is Michael Sedelmeier. I'm working at the University of Stuttgart in the area of visualization and virtual augmented reality. I'm really looking forward to a fantastic panel discussion. We have five great panelists. We have Marc Baaden here, who's working in chemistry and who's waving now. He's our domain expert. We have Tobias Günther. He's like a core viz person. We have Enkelejda Kasneci, who is a professor in human-computer interaction, a local one, if we can say that, of course, in virtual times like that. But in Tübingen, we have Torsten Kuhlen, renowned for VR, AR research. And then we have Falk Schreiber, I think, who is one of the people who invented the term of immersive analytics. So I think he should know what he's going to be talking about. So, so the panel will be organized as following. So we will have 7 minutes introductions of the 5 panelists, and then we will have like an open discussion. Everything is different in those times, as you know, but like we have a Discord channel. If you have any questions at any time, you can post them there and I will pick them up and ask them later on. I hope you're going to be active. If not, of course, I have thousands of questions about the topic, but it would be great if the audience is also active in that sense. So without that, I want to, without further ado, I want to switch over to the presenters. We will go in the order that I announced the speakers. And then again, if you have any questions, please put them onto Discord. So the first speaker will be Marc Baaden. I'll keep the introduction short so we have more time for the discussion later on. Marc, the stage is yours.
Thank you very much, Michael, for the very nice introduction. I'm very glad to be here and to talk about this exciting topic. Now I'm taking on the hat of the domain expert, so I'm a computational chemist. And so we have increasing pressure, I would say, to kind of deal with all the data that the people generate. And I try to prepare a few slides. So I will try to share my screen. Hopefully this time it works. Let's see. Where is... Okay, why can I not find Keynote? I just try to do it like that. And do you see my screen? Did that work? Yeah. So you see something about data and databases. This is kind of the background where we start from. I work a lot in biology, a computational study of biological systems, or a lot of structural biology. And we have a lot of course, experimental data, the protein data bank, EM structures, integrative biology. Then in the lab, we do a lot of computational work, for instance, molecular dynamics and modeling that generates another wealth of data. And from bioinformatics, you get a lot of also mashups where data from different sources is combined, can be GenBank, UniProt, and you name it, into a kind of meta databases that also provide very valuable input. So I will just a little bit for this introduction focus on molecular dynamics because that's what we do a lot in the lab. And for those of you who wouldn't know, that starts typically on a supercomputer where you would compute these simulations for quite some time, a few months, generate quite massive data. Of course, backup, and then try to pre-process them to get some subset of the data to the lab. And then starts basically the analytics loop where you would do some visual inspection on your workstation. You would do some specific analysis, and then you form some hypothesis and get some ideas, and then do some further processing. Of course, this is a cycle, so to speak. And sometimes you go back actually in the cycle, you need to launch new simulations, and that goes on for quite a while. And all this is very, let's say, manual. It's not like a nice workflow. It's just people combining scripts and whatever. And I think for this whole process, we would like to need something like immersive analytics, make this whole cycle more interactive and be able to really get into the data and not spend so much time in how I get from one step to the other in that process. So I try to formulate it as one sentence I think what we would like to achieve is to enable the scientists to use advanced algorithms and interactive exploration to uncover some patterns in their data that are not so obvious to get to. And just to illustrate this, and with my final slide in pictures, so the central one here would be an example of what comes out of these MD simulations, some animated movie of a system that you're interested in. But then you do not only have a single simulation, you typically have tens, nowadays hundreds of them. You also have how this protein is connected in a metabolic network that you need to take into account. Then you have lots of experimental data, different scales. You have bioinformatics data, and all these different scales, you need to connect them and make sense of them in your analytics. And I think that the immersive approach is really very promising to get there because of these multiple dimensions. And thank you. Well, I will skip that very much for attention. And so I stop to share my screen and give back to Michael.
Great, thank you very much, Marc. So next in line will be Tobias Günther, who is an expert for scientific visualization and also other types of visualization, who will give us a little introduction. Please don't forget to post any question that you have onto Discord. Tobias, the stage is yours.
All right. So thanks for the introduction. I can try to add a little bit of perspective from someone who mainly wants to use the immersive technology to solve problems in visualization, or to solve visualization problems in that sense. And so, yeah, very obviously, there are many great opportunities that reside there under the surface, right? First of all, we are in an actual 3D environment now, so we can use the third dimension and make use of the improved spatial perception. Depending on the setup that we have, we might have ways to interact with the real world. We can have maybe tangible objects that we can move around to have a more playful experience, perhaps. And then, of course, the strongest strength here is that we can augment the real world, right? We can show things that are otherwise completely invisible to us. But then this also goes along with a couple of challenges. For example, all the technical things that are things that can be sorted out, like the robustness of the spatial tracking, the weight of the devices, the potential discomfort we might have if we work with these things for longer periods of time. So these are things that are going to be improved, that will get better, and these will not stop us from using these kinds of technologies in the future. And then there's some other things that we might need to deal with or find ways to, work around them. And this is, for example, the issues of perception. Again, depending on the setup, but when I think of augmented reality, it depends on the real world scene in which you are standing, how much contrast you have, whether you're indoor or outdoor. And so color perception might be a bit compromised here. But then again, we have many other options, how we could encode information. We can pick any of our favorite visualization channels of size and shape and orientation, position, and so on. So we can avoid some of these issues at least. And now, as someone who would like to use this technology, I'm always asking, okay, what is the next problem we can solve? And the question now is, from all the problems we might have in mind, which of them are really worth solving with immersive technology? And the answer to this is usually somewhere on a spectrum. Is it worth? It's somewhere between yes and no. And now this is a bit, a matter for discussion, right? What for you makes the problem worth solving it with immersive technology or not? And so one input to this on the spectrum of no would be to say, well, in my eyes, it doesn't make too much sense to solve problems that we already have standard solutions for, right? Just extending it and saying now we do it in VR might not actually improve the solution of the problem. It might be slower, it might have perceptual issues, we might have less precision and so on. And then there's some gray area in between. And then on the very other end, we have problems which we could call like killer applications, where we could say, okay, if I'm presented this problem, then my first response should be, all right, where's my VR and AR devices? Where's my immersive technology? Because this problem can only be solved with immersive technology. And that's basically the Holy Grail, right? That's what we are looking for. And there's a couple of things that are relevant for this. So first of all, we should not have standard solutions to this. And then it should be problems that we cannot solve without it. And this means these are largely problems that just arise in the context of using immersive technology. And so, yeah, what are opportunities that we have here? We can look into cases where we break physical limits, like looking into objects, looking into the future, to pre-visualizations, for example, of buildings. When we walk over a construction site, we can see already what will happen in the future. And then problems that arise in the context of immersive technology, for example, make use of all the space that we now have, all the canvas that we can draw on, like automatically translating road signs, or put the information I really need in this moment, put an arrow there that says home, right? That's all I need in this moment. Or use screens, like places in the public spaces, which we can use for advertisements. This, I think, is one of the big driving factors that will lead to commercial success, because it's quite disruptive in the way how we as humans would communicate with each other, how we have access to information. Right now, you would have to pull up your phone to get additional information, but in the future, when everybody of us walks around with an AR device on our head, this information might just spring at us, and we might have so much information to filter and to decide what to actually see and what to explore, that this will be an interesting visualization challenge, to filter this, to navigate through this wide range of information. So yeah, that's from my side.
I give you a little applause because this is weird in those times, but please feel free to, like, give a virtual applause on the Discord chat as well. Thank you very much, Tobias. This was a very interesting perspective. So next one up will be Enkelejda Kasneci. I hope I pronounced it correctly this time. Who is an HCI professor at the University of Tübingen, and who will give us her perspective on immersive analytics. Please don't forget to post your question on Discord. I think you need to unmute yourself.
I mean, it's so, I'm so sorry again. It's just like, it wouldn't give me the chance to unmute myself while I'm in the screen share modus. So, okay, I'll retry that. Thank you very much for the introduction, Michael. And I think like Tobias and I are really on the same line here. I come originally like from the area of gaze-based interaction. So I'm interested in using the gaze modality as an input modality for interaction with computer systems around us. And when it comes to the question of immersive analytics, you can imagine that while gaze is, or eye tracking, actually to be more precise here, is coming already with VR and AR devices on the market. We can think of a lot of scenarios where we use AR along with eye tracking and like gaze input for interaction, which gives us an immense amount of data that has to be analyzed in addition to semantics and object information from the scene. So my motivation for the research work is making use of gaze for efficient interaction in VR and AR. And apart from the nice Iron Man, efficient and smooth gaze-based interaction with intelligent systems, I haven't seen use cases working that nicely. So it is a vision that Hollywood gives us on a very smooth interaction with systems around us using our natural input and output modalities. However, when we look at current implementations or current suggestions for implementations of AR in, let's say here, daily relevant or real life relevant use cases, such as having head-up displays, having information about traffic while driving, it looks a little bit overwhelming, right? So this is a suggestion made available by Alibaba, and it really looks like a video game. You can imagine that this basically overwhelming what we see here, and what we definitely have to think about is a lot of things to deal with, especially visual clutter, avoiding visual fatigue, and so on. So some time ago, I came across a very nice video introducing the so-called hyper reality idea. I think it connects very well to what Tobias just introduced. And it gives us, I don't think that you can get the sound, but I think it's all the visual input is very nice. And if you want to look up the video on YouTube, it's really great. The person is sitting on the bus and you have some kind of a mixed reality perspective from what's coming in on information and what's out there on the screen. Oh, so I mean, I don't know if you can still see the video. I will just scroll a little bit through that to see how overwhelming this is. So supermarket scene, for example, having a lot of input and sound regarding different things. So I think you kind of get an idea what this is about. I think for this panel, I would like to encourage discussion on these points. First of all, we need to think of efficient ways of assessing perception in AR and VR devices. We need to think of ways of avoiding visual clutter. And I think this is a problem that people express in different areas. We have to think of ways of detecting context and intentions, and we think really in a lot of applications of ways to anticipate the user's intention. So further, we need to think of ways to personalize assistance, and we have to deal with the trade-off of utility and privacy. So thank you.
Thank you very much, Enkelejda. So this opens the stage for our next speaker, who will be Torsten Kuhlen, who is a professor for virtual and augmented reality at the University of Aachen, RWTH. So like of course, virtual augmented reality is a core of immersive analytics. So I'm pretty sure Torsten will have a quite interesting perspective on that. Torsten, the stage is yours.
Yes, okay, thank you very much for your nice introduction, Michael. Just to point out once more that I'm not a domain scientist, but what you might call a classical virtual reality guy. And yeah, as such, I should definitely be an advocate for immersion. Huh? And to the question whether immersive analytics is useful, maybe even superior to visual analytics, I should answer with a clear yes. Otherwise, I would just saw the branch I'm sitting on. Oh, I should switch my slide. Here we go. Yeah, but let me tell you that my honest answer is that I'm at least somewhat skeptical and that I don't even really know the answer yet, although this might not qualify me too much here for being a panelist. But let me in the following share some of my experiences with you, and my point of contact with immersive analytics was neuroscience. Yeah, so why neuroscience? Neuroscientific data analysis might be considered as somewhat of a killer application. So Tobias already used this term killer application, yeah. And neuroscience, just because if immersive analytics cannot make it into this field, it will probably not make it anywhere else. And the simple reason is that in neuroscience, we are facing an extremely complex and heterogeneous situation with data coming from different modalities and sources, and at very different scales, ranging from the molecular data, but up to the meter scale, what we have in behavioral neuroscience. And neuroscientists produce experimental data as well as simulation data, especially in computational neuroscience. And there exists a bunch of very different research questions and analysis tasks on these data. Yeah? Also, besides abstract data, there is a considerable amount of geometrical 3D data in the field as well. So all in all, it is rather well accepted in the neuroscience community that integration and interactivity are key to success for an appropriate data analysis. So yeah, this definitely calls for visual analytics at least, but okay, the big question is, does this also call for immersion? Yeah, and we've been working in this respect for quite a while, and I'm happy to share with you some of my experiences that I could collect during my collaborations with neuroscientists. But first of all, just to tell you, immersive analytics is not just about head-mounted displays, although these HMDs have produced this second hype of VR just a couple of years ago. So clear, one size doesn't fit all, and I think it is clear to all of us. Yeah, and in this book here, yeah, where I only made a rather small contribution, but of which Falk is one of the main authors, and I think you, Falk, will comment on this book as well. Yeah, in this book, you find a much more elaborate characterization of immersive analytics, which definitely goes far beyond just using an immersive display along with otherwise standard data analysis. Yeah, and in fact, it turned out that at least in my collaboration with neuroscientists, they rate comfort and efficiency as much more important than full immersion. So our experience is that semi-immersive displays, like for instance, the one you can see here, which fit into their office environments, are quite handy for them. And if it has to be a head-mounted display, then in a seated setup, please, like here and here, just for the reason of comfort. But this also means that all the fancy embodied virtual reality interaction and navigation techniques, like real walking, redirected walking, that presume a standing position, they just do not apply anymore. Instead, different aspects suddenly become relevant, such trivial things like how to use the physical keyboard when wearing a head-mounted display. So this is what we are definitely dealing with. Yeah? Let me also mention that in terms of semi-immersive displays, large stereoscopic display walls like the one here have gained some popularity in the neuroscience community, at least with our collaboration partners, especially when a bunch of different views is needed. Yeah? This is, for instance, the case in computational neuroscience when researchers want to compare multiple simulation runs. So here you have 3 of them. And in this example, only the geometrical views of the brain, they are rendered stereoscopically and in an egocentric perspective, while abstract data like activity patterns of simulated neural networks, for instance, they are just rendered in a 2D fashion. This is how it works pragmatically with our collaboration partners from neuroscience. yeah, once more, neuroscientists and maybe scientists in other domains as well, they do not take care about the illusion of presence at all, which is normally the holy grail, though, in most other applications of virtual reality. And instead, efficient interaction concepts are their utmost priority. And this definitely means that an immersive analytics tool should definitely keep the strong concepts already developed in visual analytics, and that it should also provide a seamless integration of the domain scientists' established workflows. But what is amazing is that this, at least my experience, domain scientists are very, very open to go for new ways of interaction, like natural, direct, spatial 3D interfaces. And this, of course, gives a lot of hope for HCI research in the field. Yeah, my last slide is again about the core question from the beginning, whether immersive analytics might in fact be superior to visual analytics. And yeah, unfortunately, apart from providing some meaningful use cases that might count as success stories, this is very hard to prove in general, just because systematic studies, at least in my opinion, are very difficult to do. It might be surprising, but even for immersive visualization, as a combination of Scivis and VR, there exist only very few systematic studies. Although here, I would say, the fruits seem to hang much lower as compared to immersive analytics, just because immersive visualization is by definition about the analysis of complex 3D geometries. So the benefits of VR might apparently be more evident here. And in fact, the only systematic study I am aware of is this one here from Doug Bowman and his team. They looked at the effects of immersion to the analysis of volume data. And in a nutshell, they could indeed show that immersion makes a positive contribution to the user's performance. Yeah, but apart from these Bowman studies, we must see that systematic studies in immersive visualization are still in their infancy. And this seems even more true for immersive analytics. So there's still a lot of work to do. And this is also probably a point we can discuss today in the next 60 minutes. And yeah, I'm looking forward to this. So these were my comments, and thank you very much.
Torsten, thank you very much for this opinion between like the optimistic person and devil's advocate. That's great. And so our last speaker for today will be Falk Schreiber, who gets another 7 minutes to introduce his view on immersive analytics. And then don't forget, there are 60 minutes of discussions. Please post your questions on the chat in Discord. I think we have like roughly 4 questions. You guys can do better. We need at least 10. Come on, go. And Falk will be very provocative, so many questions. Falk, the stage is yours.
Thank you very much, Michael. Thanks for organizing this panel. Also, thanks to the other panel speakers. I may share some of their views. So just as a short comment, I basically see myself here in 2 roles. One is that I do research in immersive analytics on the basics and theory, but I also work in computational life sciences, similar to Torsten, and work on lots of applications. What I would like here to do is to share 2 opinions or maybe statements with you. And I hope that we can discuss this then in the panel and with the participants. The first one is, I think in immersive analytics, software will become more and more important, and also we need better software development. What do I mean with this? At the moment, if we talk, we often exchange the newest specification of some hardware devices, such as the head-mounted displays or an AR device. However, the hardware, in particular for virtual reality and augmented reality, gets cheaper and cheaper. And if you look 20 years ago, only some specialized labs or companies could afford a cave. Nowadays, in particular, the newest devices which come out now are so good and so cheap that everybody can afford them, every lab, every office. And that's a bit like we have seen in computer science, in my opinion, where in the 50s and the 60s of last century, hardware was expensive and software was basically free or at least cheap. And only later in the 70s and 80s, the value of software rose, and software became the expensive part, and big companies like Microsoft, Adobe developed. Microsoft, for example, was founded in 1975, or other companies like IBM moved more into software. And I think we will see some similar thing in this area too. At the moment, we have some languages and environments such as Unity or Unreal Engine, and we have games for immersive 3D environments. However, there is no good software for everyday work, for everyday data analytics, for example, or for authoring frameworks and so on. And I believe that's also a big potential for computer scientists in general, and computer science, and also maybe for new companies to look into this area. That's the one point. And the second point I would like to address is that, and this thanks to Torsten, who already partly discussed this, I think there is some misunderstanding of what immersive analytics is. It is not equal just to 3D or VR or AR. It's actually, this is all part of it, but immersive analytics is more than just 3D. The initial idea, the key idea was the immersion into your data. And that comes more from psychology than from computer science, in the sense of that the idea was looking at flow. Flow in psychology is this being immersed in a task that you basically forget your environment. You just are focused on your task and don't see anything around it. And immersive analytics, from the key idea, was to provide environments which help to go into flow if you do a specific task or work. And that can be more than just 3D. That can be sound, smell. Also, it can be a 2D visualization, as long as it supports this immersion. And I mentioned this here because sometimes in discussions I have the feeling that it's just focused on 3D. But actually, and Torsten mentioned this book already, this, can I see it? I have to. That's already in the book, so it's not new. It's already in the book that, but gets often forgotten, that immersion should also consider soundification, for example. Also in the book, you have examples of 2D visualizations for immersive analytics. And yeah, let's see, maybe come back in the discussion to this and discuss what other things than just 3D immersive analytics can be, and where can it support, or which other ways are there to support data analytics. Those are two opinions or statements, and back to you, Michael.
Okay, thank you, everyone. Here's the big applause from my side, and representing all people in the audience as well. So we collected a few questions, so thank you, audience. I see you're much more active now. I will now pick up some of these questions. And before I start with that, I feel you guys were so nice. This is like everything is gonna be good. And there was nobody saying, okay, this is all crap. So I will be now this person saying this is all crap. And then I would like you to start this discussion. Okay, so Falk, I think you gave the perfect pitch for that. You said, okay, it's not just 3D versus 2D. It's really about immersion. So my hypothesis for you would be, no, it's just everything that has been there. So there's multimodal interaction. People did that. So what you're saying is, okay, we need more multimodal interaction for visual analytics. And the other thing is, then I would say, okay, it can't just boil down to 3D versus 2D. And we studied that. It's crap for abstract data, and it's sometimes good for spatial data if you also have spatial tasks. So I think Torsten had some examples where it's it showed there is some potential, but let's just assume I don't believe that. So please convince me. Who wants to start? Please unmute yourself.
Maybe I start with a rather trivial comment on whether immersive analytics is beneficial or not, and maybe you don't like that comment too much, but when I talk to neuroscientists and I have a special discussion during a coffee break with a very famous neuroscientist in mind, he just told me the marketing effect of virtual reality is unbeatable. You know? And this already is worth the effort, yeah, because money makes the world go round. We need funding, yeah, we need to convince a broader public, and virtual reality is so cool. Yeah, this is one big benefit. Yeah, of course, we as visualization, VR, visual analytics researchers, we don't like to hear that too much. Just because we want to foster scientific insight, to help the domain scientists to come to new levels of knowledge. But again, as I told you, this is rather difficult to prove, at least. But we have success stories. I have these success stories to some extent in flow visualization, which is not directly immersive analytics. Yeah? And to some extent also in the field of neuroscience, but it's not about immersion alone. It's always about the combination of immersion together with the powerful, already established interaction paradigms that we know from visual analytics, like, for instance, semantically linked views, yeah, in space and time. This is a very powerful instrument, and this in combination with 3D visualization of the more complex geometrical views, this is what neuroscientists, at least I can only speak in terms of neuroscientists because these are my collaboration partners, they tell me this is really a benefit, but these are anecdotal statements only. Yeah? So I do not have any systematic studies, just because there are so few experts, yeah? Just a few neuroscientists I'm collaborating with. Yeah? Let me also tell you, you mentioned multimodal interfaces. Yeah? So immersive analytics, neuroscience is just maybe a tenth of my activities, and in quite some other activities we are working on interfaces, including force feedback, including audio interfaces. But let me tell you that from a pragmatical point of view, they just didn't make it yet in immersive analytics interfaces, yeah? Just because in interviews I had with neuroscientists, and when I told them what are the possibilities, what are the potentials, they told me, okay, this is really nice and fancy, but we don't see any potential for our own analysis applications.
Thank you very much. I loved your first comment, which was a very honest one. It's about the money. In fact, I do have my own story here, because I got my PhD scholarship for a 3D VR visualization. And then afterwards, I did the 2D things that were really helpful for the analysts, but that's a different story. So who else wants to comment on that, like, devil's advocate statement that, it's just the old thing again?
I maybe would like to just...
Right?
Should I go, or was anybody else going?
Oh, Marc, yeah, sorry.
I just want to make a brief comment. I think maybe there's actually nothing wrong with revisiting things, I mean, if you look at like the head-mounted displays, the first developed by even Sutherland in the 60s, already looked at molecules. But I mean, it's still interesting to revisit it now, because so many things have changed that you can do things that you couldn't do. So I think you need to check regularly with everything that evolves around you. Today, what can we do if we try that? Do we have the tools that we can put together or not? And maybe sometimes the tools are not ready, and then you need to come back a decade later. So I don't think it's so bad that we revisit things and try to put old things up again.
I would like to add also two things. One is different application areas. We, for example, work a lot together with biologists who do animal behavior, and they have a lot of 3D tracking data, and they benefit from being able to see their data back in a 3D environment where they can add additional data to it, move around in this environment. So there are, I think, more kind of use cases or application cases where it can be shown that there are benefits from such technologies. But I would also like to add another aspect, which comes back to the money thing, but it's, I think, also a strong driver. So if you look at computer graphics, partly the development of computer graphics have been driven by the game industry, because games needed better graphic cards and needed better algorithms. And we see this a similar thing here. I mean, now that head-mounted displays are a consumer article and more people like to play those games in virtual or in augmented environments, we will also see more need from this side for new methods, for new algorithms to be in such an environment, to get immersed in it, to understand how to keep an immersion in it. So I think it's another driver which most likely will bring this field forward.
So I totally agree with Falk on this. I think that all of this consumer-ready products, the VR and especially the AR devices, they're coming with additional challenges that we have to address. And that's where immersive analytics, and also, which for me, or to my opinion, goes hand in hand with visual analytics, really can provide some added value to the user, right? So it is where you can immediately see like what's the benefit of these tools and methods and technology overall, especially for these specific use cases. So I agree with Falk on this. A lot of developments will be use case driven, right? So to satisfy the needs of the use cases. So it's not just about getting funding or getting the money for something. It's about also getting prepared for a wide range use of especially this VR, AR devices for the mass usage, right? That goes beyond gaming or beyond pure entertainment, like making use for scientific use cases, for example, or product design, or whatever, any other challenging use cases you might think of. So their immersive analytics goes, for me at least, hand in hand with visual analytics. And there's a lot of progress being made in the last few years on both of these areas.
Okay, thank you very much. So I gave that opening question not because I'm purely egoistic, which no, I leave that comment to you. So I think a lot of the questions evolving in the chat go around that topic of, like, you know, what's really the value of immersive analytics here? And I think there's different really interesting facets of what people have brought up here. I will not go through chronologically through these questions, but try to pick them up, like, you know, by topic. And I think there's like one topic that evolves around data characteristics. So here's, for instance, from Martin Belgard. Do you think that immersive analytics can be beneficial even for data that is not inherently spatial? And I want to combine that with a question from Fabian Beck, which is, can also a bar chart be immersive if the user experiences a flow feeling when using it? Isn't that very individual for different users? So those are these users' data set characteristics. So like even like a bar chart, which is inherently, like, you know, not so good for 3D representations, as we know. And so there's, like, you know, two questions, and I'd love you guys to comment on those. I think Tobias needs to go first. No, Torsten unmuted himself.
Yeah,
good.
I wouldn't say accidentally. So it's quite remarkable that one of the two guys asking the questions, Martin Belgard, is my PhD student. So I probably have to answer somehow. Yeah, in fact, when it comes to visualization or rendering of 2D data in an immersive environment, I'm a little bit ambiguous about it. Yeah? I think from a logical point of view, it doesn't make sense to force 2D data in some kind of 3D format. But what would be nice to have is a seamless integration of 3D data and 2D data. Yeah? So it might be, again, from a pragmatical point of view, a question whether one should have, let me say, a more traditional analysis session, maybe in front of a huge monitor. Yeah. And then I say, okay, I want to bring this together with my complex 3D geometrical data. And then for a couple of minutes, I put on my head-mounted display, look at the data, put it off again, yeah, and continue looking at my 2D data, or whether it might be beneficial to integrate 2D data into my immersive environment, just because then I do not have to do the switch between the displays, yeah, which might lead to some uncomfort and fatigue as well. But then, obviously, head-mounted displays have to improve a lot in terms of resolution and everything. Yeah? Just because you all know how hard it is to read numbers and to look at graphs and diagrams from under a head-mounted display. What obviously is nice with a head-mounted display definitely is when you have a bunch of diagrams, yeah, then you do not only have a limited canvas, but you can in fact turn around, yeah, and use the whole 360-degree space, yeah, for presenting all these diagrams and establishing links in between the information. I hope, Martin, you are happy with this. Otherwise, come into my office, yeah, and we have a coffee about that.
Okay, anyone else? Yeah, Falk, please go ahead.
Yeah, can add a bit to this. I think that's a very good description. And I would even extend it. So for example, there was the question in the direction, is it worth to have 2D data and 3D environments? We're not only talking about visualization. I mean, you can also, for example, there has been work done to take a sequence and zonify the sequence so that you can better understand patterns in the sequence of specific parts of it. And again, you could imagine that in a 3D environment with stereo, you may be even better able to hear the sound of something like this. So you can combine different things, and as Torsten already mentioned, I think one big advantage is that you can really use your complete environment in a 3D environment compared to just a small screen which you have in front of you.
If I may make just a short provocative comment, I think if the, let's say, context is chosen right, even 1D data is interesting to present in an immersive context. There's a very beautiful movie about the scale of planets, where you basically move about from one scale to the other. And I think if you imagine this in 3D immersive, then you get really the idea across how big these scale differences are, even if it's just about actually the radius of the planets, right? So I think depending on what you want to get across, I'm interested.
Okay, any other replies for that question, data type? Also like Fabian Beck's question on 2D bar charts and like what immersive analytics would mean for that and whether this is a very personal thing. Maybe that's an HCI sort of question.
Maybe just a little bit of an add-on. What you can, of course, do in a 3D immersive environment is to position 2D data like diagrams at exactly the place where it belongs to some kind of geometrical data. So for instance, if you have a 3D model of the human brain, maybe with all the sections of the brain, then it might be might be quite adequate if you want to have more information about the different brain areas, than to put the information as an annotation directly in 3D space where it belongs to. This might help to better understand the spatial organization. But this is just a simple add-on.
Which is sort of the idea of displays everywhere, which you have through augmented reality. You're not bound to your physical display anymore, but you can basically put them everywhere, right?
Yeah. To be honest, we haven't talked about augmented reality too much here. At least I didn't, just because I haven't worked so much in the field of AR, and also because the AR displays are not ready yet for use, or to bring them to domain scientists because of the limited field of view and other problems. But once they become available, I think there will be a very nice alternative to all the other display concepts, especially because I know this from the neuroscience field. There is a lot of collaboration going on. People meet in a room where they discuss data. This is obviously very nicely possible in our huge cave. So I'm operating a huge cave, where 2, 3, or 4 neuroscientists can meet, discuss data. But obviously, caves cannot be the future either because of costs and footprint. So augmented reality devices, once they are once they are more ready, then I think they provide quite a nice alternative.
Kind of would like to add up to that. I mean, apart from the idea that augmented reality displays are not there yet, I think the display technology is somehow there, right? But we don't have the right tools to do like joint collaborative inspections of things. I mean, one of the points that I try to stress is that it's pretty hard to get the context and the intents, and also the working context of someone. Imagine you have a shared working scenario, like in the caves or even in the augmented reality. It's just like people, you'd have a crowd of people looking at the same presented material, but from different perspectives. So a very nice use case is, for example, imagine a surgical procedure, right? Imagine the surgery room and there's always like a surgeon and a co-surgeon assisting him, and there's just like a very concrete specific use case. So they have to share the information that they're working on. And this is a very typical example for like immersive analytics, right? You'd have the data that people about the tissue, for example, that people are watching, but then you'd have, for the surgeon and the co-surgeon, you'd have, like, for example, different visual perspectives on the same thing, right? And then that'd be the idea of, first of all, having tools to, or having above all methods to be able to detect, so what's the viewpoint of everybody on the same tissue, what's the context, what's their knowledge, what's relevant for the task that they're doing, right? So, and this is to me much more harder to infer and to get solved than any other display issues, right? Or general technological issues. So, I mean, we've all seen like the HoloLens demos, for example, on this, and this is a very, very nice use case where we see we need proper visual analytics for that. Immersive analytics, we have to get the context right. We also need to know what's what's required by a specific person to have an added value on that kind of display that the person has. And one thing that is not always considered, or very also very few researched, is in the induction of additional visual fatigue when working with all of these technologies. Of course, it's nice to have one or two-dimensional data also displayed in 3D, but we have done not yet enough research to see what's the workload, what's the cognitive load that we induce to the user by having those displays, and what's exactly the productiveness that the user has from having the things displayed in the way we think as a researcher could be beneficial for them.
Can I add just one comment to
No, of course not. No,
I think there was a very important point, which is we have still a bit of problem that for many things we would like to do, the good software is missing. So we cannot really collaborate in an immersive environment at the moment as we can collaborate on a desktop with Google Docs or with Overleaf. And as long as this is not there, then of course, such collaborative work is often only restricted to either specific use cases where people set up really a new environment tailored to this use case. What we would need in the future is really a kind of a framework or a library, which is ideally, of course, open source, where we can easily plug in different devices which work together in the same virtual environment, have the same data from different viewpoints, and allow collaboration in different ways. And that would, I think, be a big benefit, where it would be much easier than to also simply implement new applications for very different domains.
Okay, that's a great discussion. So I want to briefly come back to Enkelejda's point on like augmented reality sort of being the better VR in some ways. So let me put that into a provocative statement again. So like when it comes to immersive analytics, VR is only the old 3D versus 2D discussion, but the real benefit lies in situated visualization or embedded visualization in augmented reality with real world objects. And what do you think about that statement?
Just from my my feeling is a spontaneous reaction. Once more, I think AR plays its benefits and its potential when it comes to co-located collaboration. But apart from that, it depends on whether the real environment is in fact or has to be embedded into the analysis procedure. And this is most often, or in many cases, this is definitely not true. So if you don't need real objects in your analysis, so why going into AR instead of just using VR? Yeah?
If I might to play the ball back here, I know interaction is a bit hard in these virtual situations. It might be better in VR. But like very often it's not just about like the physical objects, but I think like, as you mentioned, like collaborative settings where people work together and you actually see somebody else instead of seeing their avatar. Like, you know, we all know avatar design in virtual reality is a really hard problem, specifically if you want to do like, you know, some serious conversation and decision making. Wouldn't that be like, you know, a great benefit? Maybe it's just the display everywhere idea then, but like I can imagine there's like, you know, some data flying around, but like you see the actual people interacting with that.
Yeah, this is exactly what I meant. Yeah.
Okay.
When it comes to collaboration, co-located, yeah, then AR should be the name of the game. Yeah, maybe it will be the name of the game in the midterm future in principle, just because it makes it much easier possible to combine let me say, classical analysis with immersive analysis. Yeah? Just because under a see-through HMD, you see the physical keyboard, you even see your computer screen and everything. And then if it is appropriate, you just turn your head to the right maybe, and then you have the hologram of some kind of, I don't know, a virtual brain or something. Yeah. This can definitely be the future. But again, since we are collaborating with our domain scientists now, and we have to provide solutions now that they really make use of, and since the AR display technology is not ready yet, we do not have any other chance than to go for VR, at least if we want to go for immersive analytics. But we should take care that everything, or all the features we develop, can in principle be used in an AR setting as well, so that we do not have to start from scratch again once it comes from VR to AR.
Okay, great. Thank you very much. Let me jump back to some questions from the chat. So Michael Krone was very active. I don't know why. But like he posed many questions here, and they're long, so I will like make them shorter. And one is about augmented reality, and it was specifically for Enkelejda, but I think everyone can answer. And for me, the question is really about diminished reality. So in augmented reality, we can remove objects from reality, which could be an interesting idea of like doing analytics. So like just imagine you remove your like, you know, annoying colleague, and then you can focus more on your analytics. Is this something you think could fly?
I think so. No, just a joke. So Michael and I should definitely have a chat separately. I mean, we're just sitting one floor away from each other, so we should keep discussing more on augmented reality. But to you now, Michael, I think I'm on this idea of like always on displays, right? At some point, you know, you guys might have seen those Netflix ideas or of having some contact lenses as displays in the eye, right? So it goes towards mixed reality. We're not there yet, but even augmented reality glasses or the glasses that are available on the market are not there yet to have that. But I think kind of a little bit, let's say like when working solely with VR, we have the problem that it's a very closed up environment. Okay, so on the one hand, it's very nice because we don't have to care about semantics of the scenes that we see. So we don't run into problems of the mixed reality, but the situations that we have there might work, or the use cases that we can help with there might be nice. So in some areas, it could be a nice collaborative tool, but for many other areas, and you mentioned like collaboration or even education, training, all of this use cases are hard to implement, right? Even like what's the best way to design a virtual avatar we would like to communicate with, for example. It's not easy. So it's better to have the real person there. Imagine some conferencing tools or whatever applications you might think of. So I think that on the long run, we will have like the winner are those technologies that are really, that can get to the masses. And what's a technology that gets to the masses is a technology that is helpful in daily life, like forget about those complex collaborative scenarios, even having something like a navigation scenario, like, so just having those glasses on and having Google Maps, for example, run on these glasses and showing what's the best way to find to some place of interest that I want to visit in a city, something like that. And then just like thinking of other more complex scenarios, even that kind of navigation is not easy to implement, right? So for the moment, we're not there yet, but I think it's worth putting a lot of effort and doing research in those areas. So towards some personalized ways of really developing beneficial systems for the user. So.
Anyone else wants to comment? Tobias?
Yeah, maybe to add a little bit on this thought. So in order to reach the masses, right, to reach everyone, one hurdle there is privacy, I think. And this is maybe something where the diminishing part could also help, because you could think of, if you don't want to have your information shown, maybe you get pixelated, right? Or you get inpainted and you're removed.
Like your background.
True.
Okay, great. Unless there's anything urgent, anything else urgent left for diminished reality, I would go on to the next question. I'm not seeing anyone shouting. So there's also a few usability sort of questions that I've seen in the chat, which are interesting. And one was by Shivam Argawal. So he says, like, he's new to immersive analytics, so please excuse my naive question, which I think is a great question, by the way. While looking at visualizations in immersive analytics, users need to turn their heads to see what lies outside their field of vision, walk around or perform interactions to narrow their focus. How is that different and or better than usual concepts in visual analytics, like linked views, focus and context, brushing and linkage? I think at the heart, the question really goes like, what's the actual value of immersive analytics or VR visualizations over classical visualizations when it comes to interaction?
What I can clearly say, and I repeat here from my brief introduction, is that the immersive aspect or the interaction aspect of immersive analytics will, and doesn't want never replace the established powerful metaphors that we already have in place in visual analytics. So trying to do immersive analytics without link views, without focus and context, without brushing and linking, this will never work. Definitely. This is my experience with neuroscientists, and I think this holds for any other domain as well. Yeah, this is maybe my first comment on that. And then again, walking around, also something I addressed in my introduction already. It in fact turns out that most people tend to sit in their offices. This is different from kids playing games, standing in the living room and waving hands and killing monsters or so. No, they just want to sit there and analyze their data. And this brings us to very special interfaces. So the typical interfaces we have in VR that many VR researchers are working on, like for instance redirected walking for navigation, they don't really fit so much here. Instead, the question is how to navigate through 3D data, for instance, a complex three-dimensional graph with thousands of nodes where you have to identify specific structures within the graph. This is, for instance, something that we've been working on. And you are sitting there. How do you navigate? Do you navigate with your simple mouse, or do you have a joystick, or what should you do? And then it might come to cyber sickness, just because you are not moving yourself. So the vestibular organs tell you you're not moving, but your eyes tell you you're moving. The classical aspect of cyber sickness, which you do not have when you do real walking or redirected walking. So you have to think about this. And for instance, we made some experiments that had the result that in an immersive analytics session, for instance, traversing a graph, yeah, it makes a difference whether you just use a joystick or whether you navigate by leaning forwards, leaning backwards, sidewards. Yeah, this in fact can reduce cyber sickness, and these are all aspects we have to think about. Yeah, because we don't want to make our domain scientists fall ill. Yeah, so these are all aspects we have to think about, definitely.
Thank you very much, Torsten. Let me jump in with a comment and a question back here. So like first the comment, there could be something like healthy analytics where you actually need to move around, because I think one of the big issues we have in our society at the moment is like back pain and everything. And we know what we're talking about as old computer scientists here, right? But this is something maybe you want to comment. I'm also very happy that you're bringing up the point of like 3D networks and like, you know, how we can traverse and interact with them. So I have a strong feeling that the main interaction principle, or like the main analytical principle, is really aggregation and abstraction here. So I think like it's really, really hard to find something meaningful in a huge graph if you don't know what you're looking for. And so like, let me ask the question to you, Torsten, but like I would put out this hypothesis, like, you know, walking through a 3D network doesn't make that any better. I think like, you know, that's really a more abstract problem. Can you counter argue that?
I would say I cannot really, yeah, it's in fact difficult to say. So if you so what we have a little bit of experience with is a complex neuronal networks, not in terms of deep learning, but in terms of biologically realistic networks. Yeah? And there are obviously millions of neurons. Yeah? And it's very difficult to get an overview there. Yeah? And you have the 3 dimensions, but on the other hand, you do not have so many psychological aspects of 3D visual perception that you have, for instance, when you walk through a virtual architectural scene. Yeah, you only have lines, yeah, maybe small spheres or whatever. And at least anecdotally, I can tell you that that presenting these networks, not only stereoscopically, but especially leveraging motion parallax. This makes a big difference. And in fact, domain scientists, let me call them our customers, they say, okay, stereoscopy is not so important for me, but having motion parallax, this gives me the idea how everything is arranged in 3D space. But again, there is no systematic study about it.
But that
not from our side.
Some of the studies that people in physical visualization have found, right? When you print these 3D networks, but like, I'm still skeptical, but that's okay.
Yeah.
I see like the audience has been super active, and that's great. Thank you very much, audience. Also, I'm not seeing you. So I will go on with a question from Helvig Hauser, and then I will actually go through like, you know, the question that came afterwards. So if you feel I have not asked one of your questions from like, you know, before, please just put it into the chat again. Make it shorter, and then like I will ask it. So just that nobody feels I forgot them. Okay, so Helvig's question. Given the pretty large sector of business intelligence, BI, are they into immersive analytics?
Again, maybe I can contribute a little bit to this question, but not perfectly. So here in Aachen University, we have what we call a cluster of excellence, so a huge project. And a part of this project was not about business intelligence, but it was about production intelligence. Yeah, so a word invented from within this cluster of excellence. Of course, production intelligence is a little bit different from business intelligence, but let me just comment that a small part of this project was factory planning, not only taking geometries into account, but also abstract data like material flow, like costs, like Excel sheets, and so on. So in principle, it was a little bit like in neuroscience, where you have the brain as the basic geometry, yeah, and then you have a lot of abstract data around. Yeah? And this was not so different from what we had in production intelligence, yeah, where we obviously had some automatic optimization algorithms, not developed by myself, because I'm not an expert here. And this was combined with interactive sessions, because you cannot do everything here automatically. The optimization of a production site layout, for instance, yeah, there always has to be some interaction with users, with experts, and this came to quite a nice application that is also described in the book on immersive analytics. Yeah, and maybe this might serve as an example, although I know that this does not precisely and perfectly answer Helvig's question here, because again, business intelligence is somewhat different.
Who else wants to comment on business intelligence? We all know, like tools like Tableau, they flew and they brought in lots of money. So that would be a cool thing. Okay, so Enkelejda, I see you unmuted yourself.
So actually, I didn't want to add on business intelligence. I was just like, I'm kind of under the impression, I mean, if you see like HCI research, for example, like designing proper user interfaces, there are some kind of laws that you have to follow, and there's some kind of, you know, like ways to validate your design, right? Or to compare different designs. Okay, so what's the efficiency of using something against other designs, for example, right? And I think in all of these domains, we kind of lack the standardized ways of comparing things. I know it's very hard, right, to do. So because it always requires some kind of domain knowledge or knowing what the user wants to do with some kind of visualizations or analytics or whatever. But I think that the community should do some attempts to come up with ideas on how to evaluate things against each other, exactly in the way of being able to quantify what's the benefit of presenting a user option A versus option B, right? Or having the user confronted with immersive analytics at all, right?
Thank you so much for bringing that up. That was indeed a question I had on my list also, which is like, what new evaluation metrics do we need? Because it's probably in the beginning, if we just look at time and arrows, like immersive analytics probably will lose. There is some like, you know, immersion metrics that we could use, but are those the right metrics then also for immersive analytics? So does like good immersion mean better analytics in that way? And then there's like insight-based approaches for evaluation in analytical situations, but those are really hard and tricky also to quantify, or like, you know, more qualitative stuff. So maybe before I go on, like, you know, to the next question, maybe that's also something other panelists would like to comment on, the evaluation and the metrics for evaluation for immersive analytics. I'll play the ball here. I think like Marc and Tobias and Falk could answer something interesting here in that order.
Okay. Well, I think the evaluation is one of the trickiest parts, and I think it's very difficult. And you know, from getting enough users to make user studies, and from having a good problem. So we really try to develop things more in the context of the lab, that we get lab mates to use them, and then we hope after some time, you know, a few months or years, we get some feedback that we can learn from. I think it's very difficult, you know, if you want specifically now test one method or so. I don't know. I think it's extremely hard. I have no solutions to offer.
I fully agree. And so I think maybe what could fit in here very well is Fabian Beck's next question, because it goes exactly into that direction. Because personally, I believe for these like young technologies, it's really tricky to like find a quantitative way of evaluating that. But we can collect case studies and success studies. So, and this is Fabian Beck's question, curious about success stories. Do you have experienced sessions of productive, collaborative, immersive analytics? So do we have like at least one example that we think like it's worth following up? I think Torsten and also Marc's introductory talks were going a little bit into that direction. But like, you know, give us like, you know, in 30 seconds, your favorite example that you tell other people why this is so cool for collaborative settings.
Maybe I only repeat myself in this respect, but in terms of neuroscience, obviously it happened that a bunch of quite some neuroscientists meet, in this case in a cave-like environment, yeah, and they discuss different parameters of simulation runs for huge biological neuronal networks, yeah. And they do this by means of geometrical views of the brain areas, and of course graphs, yeah? But they also do this by means of statistical information, activity patterns, and so on. And there was, by the way, also another question related to that from Fabian. Not sure multiple link views work as well, blah, 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 blah. And I can tell you they work perfectly, yeah? So it's nearly exactly the same as compared to what you can do in a desktop environment. You even have more physical space and pixels to do that, yeah? And this might serve as some kind of success story, although yeah, I cannot prove that without the immersive aspect, the scientific insight would have been the same. Yeah? This is a comparison that is extremely tricky to do. Yeah? For many reasons, yeah. Also because you only have a few experts, yeah, to do that. You cannot just take students, yeah, maybe 50 students or so, yeah, and let them do these analysis tasks. You need experts for this. So the best thing you can do is to have a use case with an expert study, maybe 4 or 5 experts, yeah, and then it comes to a success story. But again, I cannot prove that if I used a desktop for exactly the same analysis task, yeah, then the output would have been the same, yeah, in terms of also efficiency, of course. Sometimes it might be okay also to say, okay, I would have had the same output, but in an immersive environment, it doesn't take that long. Yeah? It's just about efficiency. Yeah? This might also be an aspect. Yeah?
So thank you very much. I saw Enkelejda, you unmuted.
So I'd kind of like to back up on this. Sorry. I think the one way is definitely, basically it has to be like use case specific, some kind of use case specific evaluations. Of course, one measure could be efficiency, right? Seeing like how quickly do we come up with the result, but also one other thing is the user's perception, right? So what is the user experience with the immersion, right? So what it might be not like improving a lot the efficiency, for example, but might be much easier to work with, for example, right? So we need to quantify not only task-related performance measures, but also like user experience at the user experience level, pretty much like psychologists do in the studies. And we have to provide those success stories, make them openly available to the community, right? So if people start designing similar tasks, I know it's very hard to come up with something that generalizes across tasks, but at least we could think of ways of designing, let's say like ways to capture like the user experience with this kind of immersion or technology. And then the other thing would be defining in expert studies. I think like that's the only way to go, defining with experts together, defining measures on how to quantify the
Okay, I think there's some bandwidth issue.
Maybe I can jump in and add a bit to this. I think one point is really important here, which is all those studies are still very technology dependent. So coming back to Torsten's example, we also have very good experience with collaboration in cave-like environments with biologists, for example, for metabolism. On the other hand, we also, in this area of animal behavior, we did one study where we implemented an immersive environment on many different devices, head-mounted displays, augmented reality, stereoscopic display walls. And there, for example, collaboration at the moment only seems to work well if you have, for example, the stereoscopic wall because people stand in front of it, whereas they prefer, for example, the head-mounted display because for a single investigation because you're much more in 3D than with other technologies. And so that makes it maybe a bit difficult to make general statements about immersive analytics here, because it still is not, I'll say it a different way, it still depends a lot on the technology you use for being in immersive environments.
So thank you, Falk. So in fact, I was jumping back to old questions because I felt like, we should also appreciate people who asked the first questions. They were really brave. Michael Krone was among them, and Lars Linsen, who both asked about the actual technology behind it. So which display modality do you think would be most suitable or useful for Marc in biology, but also more generally, but also for Marc, is it just about stereoscopic? So maybe you can quickly comment on that, and then I would take one other question before we go to the concluding round.
I think I very much agree with what has already been said. If we had AR devices that were technically good enough, I think that would be the thing that would most easily be adopted. Right now, the best thing we have around for me is the VR headsets.
And do you think it's mostly the stereo part of the VR headsets, or is really the immersive, like entire VR experience?
No, I think it's the entire VR experience. We also have a stereo display wall, and the immersion of the VR really helps, I think, with getting focused on a specific data set.
Great, thank you. So we have one last question from Michael Krone. He asked so many questions, so I need to read some of his, otherwise he will be like, incredibly angry at me. So here's a question for Tobias, who mentioned it's a no if good standard solutions already exist, but this seems to restrict research. How to know which ideas problems are worth revisiting?
Right. I mean, this is not meant as a hard no, so that you can't do research that you want to do, right? You never know what the output in the end is and what inspirations you can draw from it. But I think there's this risk that we are in the bubble of always solving the same kinds of problems. And if we have the solution already, then adding the immersive part might not help us so much. But if there are still open challenges to it and immersive parts help us, then sure, why not go for it? And so apart from being in problems close to the problems that we currently solve, we could also think about all the new challenges that arise when we use immersive technology. Right? So this is more as a guidance of helping us choosing interesting problems, not restricting us. Right?
Okay, fantastic. I see the audience is becoming more and more active, which is great. Unfortunately, we're running out of time. We have 2 minutes left. And for those, I would like to do a concluding round here for the audience. If you have more questions, I'm sure some of the panelists will stay around in the chat and you can have a virtual coffee together to discuss those. So my concluding question for you would be, why would you recommend a young researcher to put his or her career into immersive analytics? 2 sentences each. We go into the usual sequence that we had in the beginning. So we start with Marc.
Huge untapped potential, and the money has already been mentioned.
Tobias.
Yeah, I think also there's a lot of opportunities to dive into new directions that haven't been explored so much. So there's a lot of uncharted area.
Enkelejda.
So there's definitely a lot of research work people can do there. And I think it's a very good opportunity to make technology really beneficial for users.
Great. Torsten.
To young people, make your life a funny life, and nothing makes more fun than working on virtual reality technology and methods. Definitely. It's all about fun.
That's great. Come to academia and have fun. That's a good message. Okay, Falk, you have the final word.
Excuse me, this is not what I told you. Yeah, it's not about academia. If you want to have fun, go to academia. If you want to have fun and make money, maybe you should go somewhere else.
Okay, but we are.
Yeah, but still, you basically take my words out of my mouth. I would say it's cool. And it has future and lots of interesting research questions.
Okay, so thank you very much. I'm very happy that we had no one that said don't do it. So it seems to be a flourishing, a great area to do some research in. Or the other explanation might be no critical minds have been invited to this panel, but this is something you as the audience can discuss with yourselves. I want to thank all the speakers, all the panelists again. I think this was a fantastic discussion. I learned many new things, great perspectives from different areas. If you have any questions to the panelists, please hang around in the chat and ask them there. And then I would like to conclude this panel session and wish you all a great reminder of the remaining conference here. Okay, thank you very much.